Hello everyone, Ashley here. So, due to the circumstances around us, I thought I'll run this lecture online, and we need to catch up anyway on a couple of lectures. And the chapter is joint distribution. The objectives are mentioned here, and we'll first of all think about or discuss what the meaning of a contingency table. You've seen these before, but we'll just talk a little bit more about those tables. Then, once we understand the meaning of those tables, we will talk about joint, marginal, and control probability distribution, which will be part of the exam question. We will ask you to come up with the distribution tables for two discrete variables. And once we do this, we will explain the meaning of two discrete variables being independent and how to test to verify independence and so on. Once this is completed, we will talk about covariance. You know what is variance. When we have one set of data, we can find variance. Covariance would be when we have two uh, set of data. And then after that, we'll talk about correlation coefficient R, something that you've heard since year one. And then finally, we'll explain how covariance and correlation are related to independence. So this clearly is connected to part 2 here. So without wasting too much time, I will focus on a contingency table. It's a two-way table where every possible combination are discussed or mentioned. We have rows and columns, and from the rows and columns we can find the marginal column and row. The total will be the marginal total, and the sum of the column total will be the marginal total for the column. And we need to understand the meaning of joint event and marginal event as well. So if we look at this table, we have 200 students. We have, let's say, two modules business and module marketing, where the grading system is different. Where in business we have grade A, B, and C, whereas in marketing we have pass and fail. So take some time and understand the meaning of these six values here: 30, 10, 35, 15, 65, 45. If I just take one example, 45 would be the number of students out of 200. So there were 45 students who got a C in business and who failed marketing. So then think about the meaning of 40, 50, and 110. 40 would be the number of students who got A in business, irrespective of what they achieved in marketing. What's the meaning of 70 here? Would be the number of students who failed marketing, irrespective of what the grades were in business. And 200 would clearly be the total number of students. It can be obtained by doing 40 plus 50 plus 110, and it can be obtained also by doing 130 plus 70. So an example of joint event would be here: 30, 10, 35, 15, 65, and 40, where they come from. So for example, getting an A in business and passing marketing, so that would be 30. Another example could be getting, for example, a C in business and failing marketing. That would be, those six numbers would define the joint events. I can talk about marginal event now, which would be focusing on these three numbers and these two numbers here. So 130, 70, 40, 50, 110 would be discussion of marginal events. So for example, 50 would be the total number of students who achieved B in business. 130 would be the number of students who got a pass in marketing, irrespective of what they've done in in business. So understand the difference between these six numbers here and the two sets of numbers, which is 130, 70, and 40, 50, 110. So this would be the difference between joint event and marginal event. So clearly now we can find the probability. So before I do this, I can calculate the marginal event here by doing sum. And here as well I can do sum. And these would be the values of representing the marginal event. And here it could be total. It is total, but it could be obtained by adding these three numbers or by adding these two numbers. So let's just focus on one here. I can find the total number of students who participated in this survey here. Right. Now I can find now the probability distribution. So this is, I want you, before I move on, I want you to remember that a typical exam question will start from here. They might ask you to give examples of joint event and marginal event. And then we can move on to the distribution of probabilities here. So, for example, we might ask you to find, so we're looking at a joint event first, joint probability first, and then a marginal probability next. So for a joint probability, clearly question will come from these one of the sorry, not one, but it could be any of these six values here. So example could be find the probability that a student got A in business and intersection and passing marketing. So A in business and passing marketing, that would be here out of 200, hence the answer here. Right, that's the example, that's one example on joint probability. I can ask you a question on marginal probability, hence focusing on either these three numbers or these two numbers here, could be any one of them. So for example, find the probability that a student got a C in business, that would be 110 divided by 200. So that would be an example of marginal probability, and you can work this out yourself. So next question in the exams could be for you to come up with the joint and marginal probability table. So I don't think I want to do this. It will take too much time, but you can calculate each one of them. I think this is one of the value we got earlier. There you go. So for each one of them, you can find the joint probability. Please make sure you try this with pen and paper. You can double check that on Excel if you want. And these would be the marginal probabilities. These five values here, 1, 2, 3, 4, 5, would be the marginal probabilities. Now, I said you should try this, but you know, if I have to do this quickly, then okay, let's just quickly try to do this. So here it would be 30 divided by the sum, and I want to keep this cell constant, and I should get 0.15. You can convert all of them to 3 dps, right? And there you go. That's for this one as well, and you can do the rest yourself. Yeah, perfect. You can do them yourself. You can click on those cells and see how we worked out, but you don't really need me to remind you about this. For the marginal probability, it's 130 divided by 200 to get here. So I can either do this cell divide by 200 and I should get 0.65. Let's try to put that to 3 dps as well. Right, and similarly here I can do 70 divided by 200. Let me put a dollar sign here on E6. You should know why I'm doing this, and I would get it. Similarly, here I can do 40 divided by 200. That would give me the marginal probability for business A. Right, I can drag this down here. Now, to get this clearly, I don't need to explain. The answer should be 1. I'm probably made a mistake here. No, it's fine. It's fine. Yeah, it's fine. For me to get this, you can add these 3 probabilities. Answer should be 1. I can add these 2 probabilities. Answer should be 1. That's up to you which one you decide to use. And I can get a 1 here. Now there's another method to find this probability here. Remember how we achieved this? I did 130 divided by 200. Got 0.650. Or there is another way which probably saves time. I don't know, it's up to you. I can do sum of these 3 numbers and I should get the same as before. So I'll let you try here and see if you get it. I'm going to delete that. Right, so this would be a joint and marginal probability table, and we can ask you as well something quite specific. Right, so these 3 numbers here, 1 2 3, would mean that probability, for example, this one probability, marginal probability for business A, marginal probability for business B, marginal probability for business C. Clearly, if you add them, you should get 1. So that would be one type of question we might ask you. So we can ask you for the general table, or we can ask you for something specific. Similarly here, I could ask you for the general table, or I can ask you for marginal probability marketing pass. Hence, I'm considering marginal probability from pass and fail. There you go. So these would be the 2 values that comes here, irrespective of what the student got in business. Right, the some properties, clearly this one is easy. We are looking at this value here. So as you can see, sum of x's and y's, so that would be the answer here. Then I can look for the sum for x rows for each one of row. For each row, it could be, so I'm talking about these marginal probability here, and so on. For conditional probability, so remember we are progressing from the table, initially the contingency table, to something here. Conditional probability, one question for example could be find the probability passing in marketing given that student got an A. So my condition is student got an A. So I'm not really fussed about this, I'm not really bothered about this. So from the pool of students who got A, find the probability that they've passed marketing. So answer should be 30 divided by 40, and hence there you go. Similarly, probability A in business but passing marketing, so the condition is passing marketing. So these are the ones who pass marketing, how many of which got A in business, so that's 30 divided by 130, and hence here. Right, and again we can ask you something very specific in terms of probability distribution, something like probability the business result given past marketing is passed, the module marketing is passed. So that would be the values here, and I'll let you think about how to get it, and clearly there you go. Right. Also understand that if you add these 3 numbers you should get 1, adding these 3 numbers you should get 1. So this is the conditional probability. I want you to practice a lot more. I think some questions are given here, you can practice, you can always double check your answer, the sum being 1. Conditional probability, that's what we discussed, the sum being 1 for each one of them. Right, okay. Independence, now this is one result that you've seen before. If two variables are independent, two events, sorry, are independent, then for example E and F, then probability E intersection F is the same as probability E times probability F. We've done that in term one, and it's something that you've come across even way before you started your studies at Middlesex. Similarly, we can find independent, we can uh, check for independent variables if this is satisfied. So let's focus on this one now. Suppose we have a coin, not necessarily fair, and we toss the coin twice. The first toss is X, the second toss is Y, and the probability is given to you. You are expected to find the conditional probability, which means the sum of these numbers will give you 0.6, and so on and so forth. If you want to check whether they are independent, find the left hand side here, here, and find and test it with the right hand side, which is here, 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 and here. So on the left hand side, probability X is head and Y is head. Clearly from the table is 0.6. From the right hand side is probability X is head times probability X and Y is head. So it's X is head multiplied by Y is head, and that is giving the same answer. Hence it is they are independent. So for all of them you have to check that they are independent. For all of them you check that the answer on the left equation is the same as the right equation. Hence if they are the same, they are independent events. This works for the coin example. Clearly it doesn't work for the example that we've been discussing about business and marketing. So one question that you can get for the exams is to test the independence, whether the two events are independent. So for example, can you test if getting an A in business and passing marketing would be independent? Then clearly the left equation, this is the equation. So passing probability of getting A in business and passing marketing, from that table we've seen this number before, you can double check. That would be 0.15. quickly here, A in business and passing marketing. You want to check that with the right hand side of the equation, which would be 0.20 times 0.65. The right equation is this, right? And the answer is different to this one. So left hand side equation is different to right hand side equation, hence clearly not independent. And once you get one result, remember I told you to check all four must be satisfied. The moment you get one of the results where the left side of the equation is not equal to the right side of the equation, you don't need to keep checking for the rest. That will conclude our testing, which is the events being not independent. Covariance, we know, we've heard of variance for one set of data. Covariance is when we have two sets of data, in this case X and Y, and it's a measure of the relationship between X and Y. I'll discuss, I mean, when I say measure of the relationship, I know you're thinking of coefficient of correlation because that has been covered before. But another measure, I'm not saying they are the same, I'm just saying that another measure of relationship between variables would be finding the covariance. It's not the same as coefficient of correlation, but they are connected, and we will see that later today. So please don't expect your value for covariance to be within the range of -1 and 1. It's not the same as coefficient of correlation. What we have to understand though, it is that it is also a measure of relationship. Another way of finding or of measuring the relationship between two variables. So we can use this formula, or we can improve on this to here, right? So this is slightly easier and to remember, and we will use this one. So let's the proof is not required for you. You can read, you can understand, that's fine, but in the exams you won't be asked to prove the equation, which you can see here, right? One example here could be this one. I'm not going to do that in Excel, so I'm going to stick to this, so you want to follow here. Let's say we associate some mark, some point system to the business uh, event, which is known as X now, and the marketing known as Y. So let's associate 12 points to A, 9 points to B, 6 points to C. Let's associate 10 points to passing marketing and 0 points to failing marketing. You know very well how to get these probabilities, so I won't discuss that. So what we want to do is to find the covariance using this formula here, right? I think it should be mentioned. There you go. And to find the covariance, you need the expectation of xy, so x times y. You need the value for expectation of x, and you need the value for expectation of y. So let's start with expectation of x and y. The formula is here, and to find the expectation of x and y, you will do 12 times 10 times 0.150, right, plus 12 times 0 times 0.050 plus 9 times 10 times this, and so on and so forth. That will give you the expectation of xy. In this case, please try this. You should get 0. Sorry, you should get 53.25 here. With regards to expectation of x, you know this formula. Expectation of x would be 12 times 0.2 plus 9 times 0.25 plus 6 times 0.55, and that should be expectation of x. Similarly for expectation of y, quickly, 10 times this, 0 plus 0 times this one should give you expectation of y. Substitute all three values, 1, 2 and 3, in the equation for covariance, and you will get 1.1575, which is a measure of the relationship between x and y. If you have to elaborate on this, because a set of data might be given to you in the exams, there you go. And if you want to find these three terms, this is how you're going to get them. So expectation of x and y can be x times y, sum divided by n, and so on and so forth. So please, I've done it here. Not this one. I've done it here, and you can practice this as well with pen and paper. So x, y, x times y, and I need the sum of each. I need n equal to 10 because I want to use this formula instead. They are exactly the same as that one, which will give you the covariance. So in the exams we might give you a table and we might ask you to find covariance. So there you go. X times y, sum of each one of them, and I'll substitute in the equation here, right, which is, I'm doing this right now, and I'll end up with 19.7, which is here, right? So that's something for you to practice with calculator, pen, paper. You won't have Excel in the exam, so clearly this is something you want to practice. Some properties, uh, if I'm comparing one data with itself, I don't think it's something that needs to be elaborated furthermore. If I'm comparing one data with itself, then clearly it would mean that I'm trying to find the variance of that particular data. Covariance of x and y is the same as y and x. still very clear because I can sub the column. I'm still going to get sum of x, sum of y, sum of xy, and I'm still going to get the same value. What if I what if I increment x by a certain amount and y by some other amount? Let's see here. I want you to focus on this one. What if I increase x by 2 and y by 5? These are the new set of, so this is x, that's y. If I increase x by 2, y by 5, I will have a new product of this cell times this cell, new sums, and I can use the same formula and I will get the same answer for covariance of x and y. So incrementing my variable x and my variable y by any amount will not make a difference in my covariance value for x and y. You can double check this. In my particular case, I've increased x by 2 and y by 5 and I still end up with 19.7. What if now instead of incrementing I find a multiple? So let's multiply x by a certain amount c and y by a certain amount d. For example, here I've multiplied x by 2, so these numbers have been multiplied by 2 and y have been multiplied by 5. I find the product and I use these three numbers. I now will get covariance 197. How do I get this? Otherwise I can do 2 times 5 times covariance of xy, sorry, here, and now we'll get the answer 197. So you don't need to do the table. The property is clear here. The multiple that I have used for x and y can be used as a product with the covariance of x and y, and I should get the answer. In our case, 197. Now I want you to be careful here. This result is quite important. If x and y are independent, then the covariance of x and y is 0. Now, very careful here. If x and y are independent, then the covariance is 0. I'm not saying the opposite. I'm not saying that if you get covariance 0, you can conclude that x and y are independent. No, this must be clear. It works only in one direction. I'll repeat the statement. If x and y are independent, then we can conclude that the covariance is 0. The opposite is not necessarily true. Proof, again, not in the exams. So let's look at an example here. We have some data given with 2 coins or 1 coin tossed twice, and you can check that the covariance is 0 here. So you can use the table above. We do have it somewhere here. Here you can find the covariance using this table, right? We know they are independent. There you go. We know they are independent, and only when they are independent should we expect that the covariance is 0. So please try to find the covariance here, and you would get a 0 there. Right, so I want you to check that yourself. Right, the value associated with head is 1, tail is 0, head 1, tail 0. You know where I'm going with this. That's for you to find the covariance. Please, you are expected to get 0 only because we've discovered earlier on that they were independent. For the last time I'm repeating, I don't know if it's for the last time, I'm sure I'm going to repeat it again. We cannot conclude that x and y are independent based on covariance 0, but we know that if x and y are independent, then covariance must be equal to 0. You have to be careful on this one. So another example here where x and y are not going to be independent when we have covariance 0. So here, this is not something that I want you to do, the mistake. You will get covariance 0, I suppose. Yeah, you will get covariance 0, but here it's a case where they are not independent. So please understand this properly, x and y independent, we can conclude covariance equal to 0, but the reverse is not necessarily true. This is one example that you can think about. We've given you a uh, sorry about this, I had to pause the lecture. Let's carry on. So let's say you have 5 cards with values here, and 5 cards, sorry, 5 cards, 1 2 3 4 5, with value of x and value of y. So you can be asked to find the joint and marginal probability. So for example, how do I get 0.2 here? That's x being 0 and y being 0. That's here 1 out of 5, hence 1 divided by 5 gives you 0.2. How do I get 0 here? For example, x equal to 1, y equal to 1. I can't see it here, so that 0 divided by 5 will give you 0. That's how I get it. How do I get the marginal probability? By adding these two numbers, this pair of numbers, and so on. Now, that's covariance equal to 0. Does it mean they are independent? Maybe not necessarily true. And this is one example where we can show. So for independent, if I move up quickly now for independent, this is what I'm trying to check here. Uh, this left hand side equation, right hand side equation, only if they are equal can I say they are independent. So let's try to find this one and this one and see. Right, so on the left side we have, let's consider this one, probability x equal to 0 and y equal to 0. That's here. And let's try to find the right hand side of the equation. Probability x equal to 0 is this, probability y equal to 0 is 0.6. If I multiply, I get this answer. They are not the same, hence they are not independent. So here the example that we have is covariance is equal to 0, but they are not independent, which I have been discussing for the last 5-10 minutes. Correlation now, quickly, briefly, year one stuff, that would be what you're supposed to do. You know how I got this. The R equation is here, R squared, sorry, the coefficient of determination. If I do a square root, please make sure you do a plus or a minus. In this case, it's a positive gradient, so you don't need to put a plus, but I've highlighted it because you need to focus on that. If the line was going downward, a negative gradient, then manually you have to put a minus yourself. So that would be my coefficient of correlation. You know how to get this, the square root of r squared, and I've just written in our 3 decimal places here. So let's see how we can find the relationship between r and covariance. And well, it's given to you here. The r can be obtained, the value of r can be obtained by having the covariance dividing by the product of the standard deviation of x and y, right? So you know how to find covariance. The next question in the exams could be find the correlation coefficient, and this is the formula you're going to use. I've quickly done it for you just to double check using this here. So the covariance is 19.7. I've used this formula here to find the standard deviation of x and the standard deviation of y. Remember, you have to do that manually and double check. And covariance divided by the product of the two standard deviation should give you the value of r. There you go. Covariance divided by the product of the standard deviations should give you the value of r, which is 0.909, which we got it here as well. So you might be asked to find something similar. I'll let you read this uh, by yourself. Now another notation for covariance, for coefficient of correlation is rho xy, because we have two variables. So what we used to know as r on one variable in on two variables, x, usually horizontal is the time. What we used to know, yeah, clearly two variables, sorry about this, uh, uh, in year one is now denoted as rho, and x and y are the two variables. And yeah, what it means here is I can I can do multiples of x. I can multiply this by 5, by 10, by 8. I can do the same thing here. The relationship will stay the same. And I hope you understand why. Uh, and I try to think about it with using this here. Okay, so the coefficient of correlation I'm talking about, not the covariance. So we've discussed that using covariance before, where the factors, the multiples would be coefficients. So think about it, think about the mathematics. So irrespective of what I do with my x or y in terms of having multiples, they are still going to be the same correlation here. Right, so one example that you can get for the exams is given the covariance. You can find the variance. Remember, I want to find R from here. Now, covariance divided by the product of the standard deviation would give me R. Covariance is given. One formula to find variance is this, familiar, you've seen this before. A square root of the variance will give you the standard deviation. Similarly, variance of y using this formula can be calculated. A square root of this number will give you the standard deviation. Hence, I can find my r using this formula, and that's what we've seen to 3 decimal places, 0.909. Good, so that's it. Similarly, you can if the covariance, if x and y, or let me just repeat this, if x and y are independent, then the covariance is 0. Now think about it. If covariance is 0, if covariance is 0, 0 divided by whatever number I have will give me the correlation coefficient 0. So that's the connection between independence, covariance, and correlation. So if x and y are independent, earlier we saw that covariance was 0. It also means that r, or in this case rho, or if you know it better as coefficient of correlation, that should be 0. In terms of mathematics, just substitute 0 here. 0 divided by this product should give me 0. That's your r, same as rho. So remember, it works only in this direction, moving from here to here. The reverse is not necessarily true, and I think maybe this is one example where rho r, your r value is 0, but they are not independent. That's it for this lecture. Hopefully we can do other lectures, and I hope you're keeping yourself safe. I'll see you next time. Thank you very much.